talk about the first derivative test. Basically, what information can we get from knowing the first derivative? Now, let's just look at this. If you have a curve that is sloping downward, that is, if instead of drawing what I drew, we drew a straight line that somewhat resembles it, it's a negative slope. If you look at all our tangent lines, you look at all the tangent lines on that portion of the curve, they're all negative. F prime of x is less than 0. Even if it went this way, it's still decreasing. The slopes of the tangent lines are all negative. That is, the first derivative is negative. Whenever the first derivative is negative, the curve either goes like this, or it goes like that, or a combination of both. It can go like this. But notice it's going down. The slopes of the tangent lines are always negative. They're always negative. Let me get rid of the graph in the middle. If the curve is going up, as you go to the right, the curve goes up. Say like this. Well, look at the value of the slopes of the tangent lines. They are all positive. F prime of x is greater than 0. Likewise, the graph goes like this. The slopes of all the tangent lines, and yes, they should be a little bit closer. Their tangent lines are all positive. Again, anything that looks like that, the slopes are all positive. F prime of x's are all greater than 0. So, we are getting ready to curve sketch graphs. We're leading up to that. That'll be on the next section of the video. So let's see. So what I'm going to give you is the first derivative, and I'm going to ask you where is it increasing and decreasing. Let's say the first derivative is x, or 2x times x minus 1. That is, it's 2x squared minus 2x. That is f of x is 2x cubed over 3 minus x squared. If this is f of x, then that's the derivative. And the first thing you should do when you have the derivative is you should factor it. Okay. Now, the next thing you should do is see when it equals 0. F prime of x equals 0 when either 2 is 0 or x is 0 or x minus 1 is 0. Well, 2 equals 0, never. 2 is always equal to 2. X equals 0 means x equals 0. X minus 1 is 0 means x is 1. We all know 1 minus 1 is 0. So we are concerned with the x values that made the first derivative 0, or I guess even, or undefined. So we make up intervals from negative infinity all the way to positive infinity, except we don't include 0 and 1. So I guess the next step is to write 0, 1, 0 and 1 in increasing order. That is, 0 smaller, 1 is larger. the intervals will be from -1 to 0, because we can't include 0. In other words, here's a number line, here's 0, here's 1. We don't want to include these numbers. So we want to include from -infinity up to 0, from 0 to 1, and then from 1 to infinity. And we want to look at the sign of f prime of x in each of these intervals. We want to know if it's positive or negative. Well, the fact is, for the derivative, are 2 and x minus 1. For example, so if you knew the signs of these three factors, you would know the overall sign. Well, let's see. 2 is always positive. No matter what interval we're in, 2 is always positive. X is positive if x is more than 0. That's in this interval and this interval. These are the x values. X is positive in these two intervals. It is negative here. Why? Because all of these numbers are negative. The third factor, x minus 1, when is it bigger than 0? Add 1 to both sides when x is more than 1. This is the only interval where x is more than 1. So it's positive there, but it's negative elsewhere. The overall sign is positive here, and negative here, and positive here. When you multiply the three factors, you get positive, negative, and positive. So a question might be is, this should have been what I asked at the beginning. Where is f of x increasing, and where is f of x decreasing? Well, it's increasing when the first derivative is positive. So when it comes to increasing, the answer is from -infinity to 0 or 1 to infinity. Union. It's decreasing elsewhere. It's decreasing where the first derivative is negative. Well, that interval is 0, 1. And there's that answer. Where is it increasing? Where is it decreasing? This table that I'm drawing, that tells you everything. Let's consider another function. Suppose I tell you that f of x is equal to x cubed minus 3 over 2x squared. And the instructions are, where is this function increasing and where is it decreasing? So the derivative tells us, first derivative test. Well, it's 3x squared minus 3x. Because when you bring the 2 down, 2 times 3 over 2 is just 3. Okay, and like I said, you always factor the derivative. I can pull out a 3x from here and here. When I pull the 3x from here, I'm left with x. That is 3x times x is 3x squared. Minus, and 3x times 1 is 3x. So there it is, 3 times x minus 1. And I'm very confused about the odds on doing this, and it's exactly the same as before. Sorry about that. Suppose the derivative in factored form. So this is how you can practice. Write the derivative in factored form. Say it's negative x plus 1 times x minus 1 times x plus 5. determining the derivative really was, just give me one moment, please. 1 minus x squared times x plus 5. The first derivative was negative x cubed, minus 5x squared plus x plus 5. That was the first derivative. Okay. So, for the record, the original function was negative x to the 4th over 4 minus 5x to the 3 over 3 plus x squared over 2 plus 5x plus 13. So, this is what you would be given. I took the derivative and then I factored it. You have to practice your factoring. 1 is 0 of f prime of x. So, using that, you can use long division to factor more. Alright. Only comment I'll say is that there's a 1 right here, negative 1. So now, when is the derivative equal to 0? So again, let me tell you, you're given the function, take the derivative, factor it. Factor it completely, big time, factor that derivative. And then see when it equals 0. It equals 0. So the factors are now underlined. The factors are the things that are being multiplied. Well, the first factor, negative 1, that's never 0. It's always negative 1. The second factor is 0 when x is negative 1. The third factor is 0 when x is 1. The last factor is 0 when x is negative 5. So now I write these three numbers in increasing order, from smallest to largest. There it is. Now if you need to draw this little picture to get the interval, go for it. It's not a big deal. We want to include every number in the intervals that we're about to write, except the ones I just X'd out. Except negative 5, negative 1, and 0. That is, we go from negative infinity to negative 5. We go from negative 5 to negative 1. And I'm putting open brackets because I don't want to include negative 5 and negative 1. We then go between negative 1 and 1. Open brackets because I don't want to include the endpoints. Then we're bigger than 1. That is from 1 all the way to infinity. And in each of these intervals, we want to see what the sign is, the plus minus sign of the first derivative. Well, let's go factor by factor. The first factor, negative 1, well, that's always negative. Okay, done. The next factor, x plus 1. When is it positive? It's positive whenever x is bigger than negative 1. That's in these two intervals. So that's when it's positive, and it's negative in the other intervals. Now the next factor is x minus 1. Right here, x minus 1. When it's positive, well, add 1 and get your answer. Positive whenever x is more than 1. That's only this interval right here. So it's positive there, but negative everywhere else. Now we go on to the last factor. I'll work it out up here. When is x plus 5 positive? Well, take away 5. Cross it out on the left side. X is greater than 0 minus 5, which is negative 5. Well, which intervals are bigger than negative 5? Well, you have this one, and this one, and this one. They're all positive. That factor is positive in those three interval, and negative in the last one. So I multiply the four negative signs and I get positive. Here I get negative, positive, and negative. If there's an even number of negative signs, the result will be positive. If there's an odd number of negative signs, the product will be negative. Okay, so let me erase what I have in the right here, and then we can answer the question. Again, the question being, where is the function increasing? Where is it decreasing? Increasing. Well, whatever is plus here and here. That is, between negative infinity and negative 5, or negative 1, 1. That's where it's increasing. If the first derivative is positive, you're increasing. Where is she decreasing? Wherever the first derivative is negative. Here and here is negative. Look right above those negative signs. Those intervals go from negative 5 to negative 1, as well as from 1 to infinity. Problem is over. This here is your first derivative test. Just try one more. Suppose I tell you that the derivative is x to the 2/3, which I guess means that the function is x to the 5/3 times 3 over 5. If you take the derivative of the top function, you get x to the 2/3. Now x to the 2/3, okay, let's slow it down. So we found the derivative, now we want to factor. Like I was about to say, you can factor x to the 2/3. It already is factored. Oh well. So it already is factored. Now let's see where it equals 0. Well, remember, 0 to any power except 0 is 1. And that power is not 0. So 0 to the 2/3 is 0. Okay, the first derivative is 0, coincidentally when x is 0. And that's the only value. So we only have one number to put in order, and it's 0. So the intervals are going to be from negative infinity to 0, and then from 0 to infinity. Every number is in one of those intervals, like 7 is somewhere between 0 and infinity. The number pi, which is a little more than 3, is between 0 and infinity. All the negative numbers are there. The only number that is not in an interval is 0. Okay, now let's look at the first derivative. Okay, let us look at the first derivative. Well, here, so what I want to comment on is that x to the 2/3 means x to the 3rd squared. That is, it's the cube root of x, and then you square it. Now, the cube root of x, the cube root of a number, for example, the cube root of negative 8, whatever this answer is, this is asking a question. What times itself 3 times gives you negative 8? And that answer is negative. It's negative 2. Cube root of positive 8 will be plus 2. Sometimes what's in these brackets are positive, sometimes it's negative. But when you square it, it's going to be positive. It's always positive. So where is it increasing? It's increasing where x is not 0. Everywhere else. Where is it decreasing? Nowhere. The empty set. Okay. Now, let's do the problem that I really meant to do. Suppose the derivative turns out to be x to the negative third. For the bracket, that means that the function happened to be x to the 2/3 times 3 over 2. That's the function. 3x to the 2/3 over 2. It doesn't matter that. I mean, take the derivative of this correctly, and I'm telling you, that's what you get. Okay, x to the negative third. But we have to write x in a better form. A form where there's no negative exponents. Okay, we just did that. And this here cannot be factored. Well, f prime of x never equals 0, because when you have a fraction, before you can equal 0, a necessary condition, a must for a fraction to equal 0 is the numerator has to be 0. 1 is never 0. Couldn't care what x is. When if x is equal to -1, then 1 equals 1. It's insane to say 1 equals 0. Okay, so it's never 0, but in this case, it can be undefined. Okay, it does not exist. It does not exist when the denominator is 0. And basically, we have the cube root of x. What should x be so that when you multiply it by itself 3 times, you get back 0? What should go here? And the answer is, if I want here to be 0, then x must be 0. Because what times itself 3 times gives you 0? X. I mean 0. 0. Only the cube root of 0 is 0. That x should be 0. Not clear why that troubled me so much. Okay. So, this is the only x value that made the first derivative either 0 or undefined. So our intervals will be -∞ to 0, which just excludes 0, and 0 to infinity. Now, I think we talked about how, okay, so f prime of x. This time, the derivative is a fraction. So let's find the numerator. The sign of the numerator is always positive. 1 is always positive. And the denominator, the cube root of x, the cube root of positive numbers, and these numbers are positive, the cube root of positive numbers are positive. These numbers are all negative. The cube root of negative numbers are negative. So here, negative answer, here, positive answer. It's it's decreasing here. That is, it's decreasing here. And to the right, since it's positive first derivative, it's increasing on 0 infinity. Okay. Why don't we just look at one last one? This time I won't tell you it's a function. That's not what this is all about. We spend lots of time finding the first derivative. Suppose I tell you that the first derivative happens to be x minus 1. How about x minus 4 over x minus 6? Well, I want to know two things. It equals 0 when the numerator is 0 and its denominator is not. Well, if x is 4, 4 minus 4 is 0, and 4 minus 6 is -2. This fraction is 0. It does not exist when the denominator is 0, when x is 6. So the two numbers that came up were 4 and 6 in increasing order, 4 first, then 6. So we want to make up the interval that bypass 4 and 6. You need the chart, here's 4, here's 6. If you draw 2 x's, you get 3 intervals, 1 more. If you draw 1x, you get 2 intervals. You always get 1 more than the number of points you want to skip. You want to skip 2 points, you're going to have 3 intervals. Okay, so the intervals are going to be from negative infinity to 4, then 4 to 6, and then from 6 on. That is 6 to infinity. And you want to look at the plus minus sign of the first derivative. And the first derivative is a fraction. The numerator is x take away 4. When is that positive? Well, add 4 and find out. Add 4 to both sides. Whenever x is more than 4, it's positive. Well, these numbers are all less than 4. These numbers are all more than 4. So are these. They're even more positive. So the first interval, the numerator will be negative. Now let's look at the denominator, x minus 6. When is it positive? Well, add 6 to both sides, and it's positive when x is more than 6. Okay, of course we have a typo here, excuse me. Like I said, I'm pretty sure I said it right. The last interval goes from 6 to infinity, not 4 to infinity. Sorry about that. To the record, if x is more than 4, well, sure, these numbers are more than 4. Now we have to be bigger than 6 to be positive, and this is the denominator. This is the only interval that's bigger than 6. It starts in 6, so it's positive. The other intervals are negative. So negative over negative, negative over positive over negative, and positive over positive is positive. So it's increasing wherever you see a plus sign. That is, here and here it's increasing. So where is it increasing? Negative infinity to 4, or 6 to infinity. Where is it decreasing? Everywhere else. It's decreasing where the first derivative is negative, which is 4 6. Okay, that's how you handle the first derivative test. And now we're going to talk about the second derivative test. Derivative test use the first derivative. The second derivative test will use the second derivative. Let's consider a curve that looks like that. Now, derivative means change. You have y. The first derivative is the change in y with respect to x. That is, the first derivative gives you the slope. The second derivative gives you the change in the slope with respect to x. How is the slope changing? How is the slope changing? Well, let's see. Here, the slope maybe is negative 100. Over here, it's less negative. It's still negative. I'm not going to debate that, but it's less negative. It's negative 20. Over here, the slope is 0. Notice I keep going to the right. Over here, the slope is, say, 10. And over here, the slope is, say, 200. second derivative. By the way, a curve or any portion of a curve that looks like the curve I just drew, it has a name. It's concave upward. Okay, but that's a name. I don't believe it's that important. What's important is that you realize that the slopes, the change in the slopes are increasing. The slopes are increasing. If you go from negative 100 to negative 20 to 0 to 10 to 200, you kept going higher. Owe somebody 100, now you only owe them 20, now you're even, now they owe you 10, now they owe you 200. You were moving in the positive direction. So we say the second derivative is positive. Any graph that has a portion of what I just drew is said to be concave up, and the second derivative is positive. That curve, concave up. This curve, concave up. This curve, concave up. Any portion of this, doesn't matter how big, how small, this little portion, concave up. This bigger portion, concave up. Much bigger portion, concave up. Any portion of that U-shaped graph is concave up, and the second derivative is always positive. The change in the slope is positive. It's getting bigger, getting larger. Now, let me erase this, and I have a comment to make. Like I just said, that's concave up. The second derivative, denoted f double prime, is greater than 0. But like I said, sometimes the slopes are negative, sometimes the slopes are positive. Knowing the slope, knowing the first derivative, doesn't tell you if it's concave up or down. Knowing the sign of the first derivative gives you no information about the second derivative. For the record, knowing the sign of the second derivative, it gives you absolutely no information on the first derivative. An upside down U. This is said to be concave downward, or concave down. Now let's look at the slopes. Here, the slope is very positive. Say it's 100. Here, the slope is less positive. Let's call it 20. Here, the slope is neutral, it's 0. Here, the value of the slope is negative, say negative 10. And over here, the value of the slope is, say, negative 125. We went from very positive to less positive to 0 to a little negative to very negative. The change in the slope is decreasing, smaller. That means the second derivative is negative. Anywhere on that portion of the curve, the second derivative is negative. Now, let's look at this for a moment, something that I just spoke about. Here, the slopes are all positive. The slopes are all positive. Positive, except maybe it's 0 at one point. It's positive here. Well, that's not true. That's not true. It's positive here. It's positive here. It's always positive. But you know what? This portion of the graph, it looks like part of that. Looks like that part of it. Here, it's concave down. That means the second derivative, call it y double prime, the second derivative is negative. on this portion of the graph is concave up. Why? Because it's part of this looking graph. It looks like that portion. That means the first derivative is positive. Okay. Even though the second derivative is positive, excuse me. But you know what? Over the whole interval, over the whole graph, the first derivative is positive because all the slopes are positive. But the second derivative, it changed. Part of it, the second derivative was negative, and part of it was positive. Knowing the first derivative doesn't tell you anything about the second derivative. It doesn't tell you anything. So the first derivative tells you where a function is increasing and decreasing. Somebody asked you, here's the function, where is it increasing and where is it decreasing? You should look at the first derivative. If somebody asks you next, where is the function concave up or concave down? Not a big deal. What you should do is you should look at the second derivative. Okay, for example, suppose I were to tell you that f of x is equal to, say, x2 minus 3x over 3 would be nice. So the instructions are, since we're doing a second derivative test now, where is the function concave up? Where is it concave down? So we look at the first derivative. It's 3 in the bottom is a factor, so it just stays. The derivative of the top is 3x squared minus 3. I can factor out a 3 from the top, divide by 3, so I just get x squared minus 1. But that can factor. Just like the first derivative test, you want to factor the second derivative as much as possible. Oh, that's not the second derivative, excuse me. Sorry about that. So, it turns out that the first derivative reduces to x squared minus 1. So now to find the second derivative, you take the derivative of the first derivative. And that's just 2x. Factor it. You can't factor it anymore. The first derivative equals 0 when, well, if 2 times an unknown number is 0, that number is now known. It's 0. Okay, so just like before, it's exactly the same test or procedures as before, except we work with the second derivative. Write down all the x values that made the second derivative 0 or undefined, and put it in increasing order. There was only one of them. So the intervals go from negative infinity to 0, and then from 0 to infinity. Notice I just skipped 0. If you have 0 and you want to bypass it, it's negative infinity to 0, and then from 0 to infinity. And this time, we're looking at the plus-minus sign of the second derivative. Well, the factors are 2 and x. Well, 2 is always positive. And what about x? Well, x is positive if x is positive, and it's negative when x is negative. X's are positive here, and x's are negative here. So, this is negative, this is positive. It is concave down on negative infinity 0. It is concave up on 0 infinity. I want to check out something. Yeah, let me make sure I was right. It's concave down from negative infinity to 0, and it's concave up from from 0 to infinity. That is how you do the second derivative test. Okay, so what I'm going to do is I'm going to give you the second derivative. You would get that if you have the original function, if you have f of x, and you take the first derivative, that gives you f prime of x, then you take the derivative of that, that gives you f double prime of x. And I'm telling you that f double prime of x, in factored form, happens to be x minus 4, x plus 1, over x minus 2. Now, where does f prime of x, double prime of x equal 0? When x is either 4 or x is negative 1. The values that make the numerator 0, but not the denominator. That's the plus sign here. X is 4. 4 minus 4 is 0. 4 plus 1 is 5. 0 times 5 is 0. If x is negative 1, this here will be negative 5. This will be 0. Negative 5 times 0 is 0. Okay. And notice it didn't make the bottom 0. 0 over not 0 is 0. F double prime of x is undefined, or does not exist, when the denominator is 0. We all know that 2 minus 2 is 0. Let's not forget that. So I write down all these numbers, 4, negative 1, 2, and then I write them from smallest to largest. That is increasing. Negative 1 is the smallest, 2 the middle size number, and 4 is the largest. So, negative 1, 2, and 4. Skip these numbers. Skip them. So we're going to have 4 intervals. 3 numbers. That is, we cross out or x out 3 numbers. We have 4 intervals. Negative infinity up to negative 1. Negative 1 to 2. 2 to 4. 4 to infinity. Now we want to find out the plus minus sign of the second derivative. I didn't say at the beginning, the instructions are find where f of x is concave up, concave down. Find out where f of x is concave up, concave down. So we need the second derivative. Whether we have to calculate it from f of x, or even calculate it from f prime of x, or maybe it's given to us. Doesn't matter how we get f double prime of x. Once we have it, this is what we do. We factor it. It already was factored. Find out which values make the first derivative 0. Find out which values make, I meant to say the second derivative 0. Find out which values then make the second derivative undefined. There they go. Write them in increasing order. Make up this amount of the table that you see. Okay, now we need to fill in the table. In the table, it's clearly a fraction. We have 2 factors on top and 1 in the bottom. Let's look at the first factor in top. This is positive when x is more than 4. Only this interval has x's bigger than 4. Numbers between 2 and 4 are not more than 4. It's negative. Numbers between negative 1 and 2 are not more than 4. It's going to be negative there. Let's look at the next factor on top. X plus 1. When is it positive? Take away 1. Find out. Positive when x is more than negative 1. Well, there's negative 1 right here. There's negative 1 right there. From there on, it's positive. That is, those numbers are all more than negative 1. To the left, it's negative. To the left of this mark. Now the denominator. X minus 2. When is it more than 0? And how much money do you have to have? So if you give somebody $2, they just take away $2, you'll have something left, you know, a positive amount. You have to have more than 2. X is more than 2. Well, X is 2 right there. Right there. So from here on, X is a more than 2. So it's positive, and in the other direction, it's negative. Odd number of negative signs, negative. Just like multiplication. Even number of negative signs, I see 2 of them, the answer is positive. I kind of need the space, so let me put it on top. Positive. Only one negative sign, odd number, negative. No negative signs, 0. 0 negative signs, that's an even number. Okay, so I didn't mean to put 0, I meant to put plus. So wherever it has a plus sign, it's concave up. Wherever it says negative, concave down. The table is everything above this line, the bottom line I just drew. So let me put the answer down here. Where is it concave up? That's where the second derivative is positive. If I just said increasing and decreasing a moment ago, I was wrong. The second derivative is positive from -1 to 2 and from 4 to infinity. -1 to 2 as well as 4 to infinity. That's done. That's where it's concave up. Where is it concave down? Where is it concave down? Wherever the second derivative is negative. Namely, negative infinity to -1 and 2 to 4. Negative infinity to -1 as well as 2 to 4. A lot of instructors would tell you to take test points. Don't take test points. It takes longer. X is bigger than 4. This is the only interval where it's bigger than 4. Notice that we got these 3 immediate, negative, just by solving this one equation. Here we have X is bigger than -1. I found that everything to the right of this line is bigger than -1. And I want you to think of, if it makes life easier, this top line as a number line. Right here is -1, right here is 2, right here is 4. Okay? Everything to the right of -1 is more than -1. This interval, this interval, this interval, all more than -1. That means that x plus 1, that factor is positive. We get a lot for a little. Solve one inequality and find out, in this case, 4 signs. You should not pick test values. You can. Then you have to do some math. You have to put 5 into f double prime of x. I think we had 4 factors, or was it 3 factors? You have to put 5 into all 3 factors, get the results, multiply, divide, and see if you get a positive answer. Okay, now I'm going to talk about one more thing. We're going to talk about a point of inflection. and concave up. Okay, now, to the left of this mark, that part of the graph is concave down, which means the second derivative is positive. To the right, what's in blue is concave up. That means, when it's concave down, the second derivative is negative. The second derivative is negative. That is, it's less than 0. Concave up means the second derivative is positive. But the instructions or definition, of point of inflection, it says wherever f double prime changes signs. That is, if you go from negative to positive, you must have changed signs right here, right here, right here. Right there is your POI. That's your point of inflection. It will turn out that the first derivative is 0. Well, let me not put it there. The first derivative is 0 right here. The first derivative is 0. You will never have a point of inflection unless the first derivative is 0. But, excuse me, that's where the second derivative is 0. If you go from negative to positive, you have to be 0 in the middle. Okay? The second derivative equals 0 right at the point of inflection, every time. Okay? Every time you have a point of inflection, y double prime is 0. Notice, I never ever said every time the second derivative is 0, you have a point of inflection. Okay, those are different statements. Let's write it up formally so you can have it in your notes. So let me just state it slightly different than I thought. If you have a point of inflection at x equals c, then f double prime of c equals 0. Okay? Every time you have a point of inflection, it means the second derivative is 0. Point of, in shorter notation, point of inflection means the second derivative is 0. But I never said it the other way. Okay? If f double prime of c equals 0, then you may have a point of inflection at x equals c. But notice what the first one says. It says every time you have a point of inflection. If you have a point of inflection, not sometimes, not most times, every time you have a point of inflection at c, the second derivative is 0. So, if the second derivative is not 0, you do not have a point of inflection. Now, let me just convince you of this. For example, I hope you all recognize this graph as y equals x squared, or f of x equals x squared. Well, actually, I don't like that one. I'm going to modify it slightly. It's x to the 4th. And x to the 4th looks just like that. Now, the first derivative is 4x cubed, and it equals 0 when x is 0. F double prime of x equals 12x squared. And this equals 0 when x is 0. Now, this graph does not change concavity. It's always concave up. There is no point of inflection. There is no point of inflection. It didn't happen. But you know what? So, when the first derivative is 0, you have a possible critical point. And in our case, you have a min. Now, exactly what's going on? Well, the second derivative doesn't change signs at 0. If x is a little bit less than 0, this is positive. The second derivative is positive. 12 times a very small negative number, 0.0001 squared, this is positive. 12 times a positive number close to 0. Positive. It didn't change signs at 0. But that's not true about 4x cubed. If x is less than 0, it's negative. Slope is negative. When x is less than 0, the slopes are negative. If x is more than 0, the first derivative or the slopes are positive. That is, it's increasing. Okay, not putting the flavor of concavity in, the graph looks like this. And that's exactly what that's exactly what we had. Okay, now I'll give you a function where it reverses. That is, it doesn't have a max or a min. Well, it turns out that when x is 0, the first and second derivative will be 0. But it won't have a max or min. It will have a point of inflection. Okay, so you should recognize this graph as y equals x cubed. This is y, or f of x equals x cubed. F prime of x is 3x squared, which equals 0 when x is 0. And f double prime of x is equal to 6x, and this equals 0 when x is 0. Okay, but there is a sign change here. When x is close to 0, if x is less than 0, this will be negative. If x is more than 0, this will be positive. There was a sign change. That's a point of inflection. Here, when x is 0, when x is a little less than 0 or a little more than 0, 3x squared is always positive. You have no extrema. You have no max nor min or min. So you need to look at the sign change. Don't worry so much about what I just talked about. We're going to curve sketch in a little while, and that's when this is going to come up. So you have a point of inflection where the x value, you have a point of inflection where the concavity changes sign. Okay, so why don't we just look at a curve and let's see what's up. Or let's look at a function. So I'll tell you that f of x is equal to x to the 4th minus 4x cubed. want to find the points of inflection, if any. We want to look at the second derivative. F prime of x is 4x cubed minus 12x squared. I want to find the second derivative. 12x squared minus 24x. Now we want to factor this completely. Factor out 12x, x minus 2. Okay. Now this equals 0. Now the factors have just been underlined. A lot of people would tell you that there's only two factors. One is 12x and one is x minus 2. They're wrong. Factors are separated where you have multiplication. It's 12 times x minus 2. Of course, when you multiply numbers, they give you factors. If somebody asks you to find the prime factors of 6, you would say 2 times 3. That is, two numbers, plain old numbers, can be factors. In our case, the plain old number is 12. The 12 is never 0, but x is 0 when x is 0, and x minus 2 is 0 when x is 2. So we want to see the only possible places. Remember, a point of inflection can only happen where the second derivative is 0. That is, these are the possible values, x values, where a point of inflection happens. Nothing else. I guarantee you 17. At 17, you won't have a point of inflection. Maybe at 0, maybe at 2, maybe at both of them, maybe at none of them. The chart will tell us. Okay, we're going to look at the signs of f double prime in the three intervals that these two numbers divide the number line into. We stop off at their smallest value, and we go from the smallest value to the next value, and since that was the last value, we go from 2 to infinity. And we want to look at 12 times x minus 2. Each of them one by one. Well, 12, always positive. 1, 2, 3, got it. The next factor is positive if x is more than 0. X is more than 0 to the right of this line. More than 0 up to, but not including 2, that's more than 0. More than 2 on forever, that's more than 0. So those are positive. This is all numbers less than 0. Well, that's negative. The next factor, x minus 2, well, that's positive when x is more than 2. That's to the right of this line. This says from above 2. This is above 2. Don't include 2, but include everything above. Well, that's positive, and the other ones are negative. You multiply those three signs, you get the answer. Okay. You have a sign change right here. So, you have a point of inflection at 0. You have a point of inflection at 0. Once again, you have a sign change in the second derivative. So, you have a point of inflection at 2. It turned out that both possible values, 0 and 2, were point of inflection. So you can say POI at x equals 0 and x equals 2. If they ask for the exact point, well then you have to give the y value. If x is 0, and remember, another name for f of x is y. F prime of x, y prime. Y double prime. Somebody asks you for a y value, please use the y formula. 0 to the 4 minus 4 times 0 cubed is 0. When x is 2, what is y? Well, 2 to the 4th is 16 minus 2 cubed is 8. And 8 times 4 is 32. 16 minus 32 is negative 16. So those are the 2 points. I gave you the x and y values for each of the 2 points. If they just ask for the x values, then you can just say 0 and 2. Find the second derivative. Find out where it equals 0. See if the second derivative changes signs around those 0 numbers. Okay, that completes this section.